All right, let's talk about color matching. It's one of those things that feels like an art, but it's also a deep science. Here's the thing, just trusting your eyes, that's a huge risk. But, and this might surprise you, just trusting a machine is also a risk. The real magic, the secret sauce, is finding that perfect balance between the two. And that's exactly what we're going to break down right now. I'm sure you've heard this a million times, right? It's a little too light, it feels a bit too green. These are the comments that just drive you crazy. Why? Because they're subjective. They're based on a gut feeling, which is an absolute nightmare when you're trying to be precise. So that's the real challenge, isn't it? When you're up against someone's feeling about a color, how do you come back with cold, hard facts? How do we stop arguing about opinions and start having a real, objective conversation about color? Okay, so let's jump right in. The first step is to understand that we have to go beyond just one tool. We can't rely only on our eyes, and we can't rely only on an instrument. You see, in the industry, we use incredible tools like spectrophotometers to get objective data, real numbers for color. But here's the thing that separates the rookies from the pros: knowing how to take that super precise data and combine it with the judgment of a trained human eye. That's where the expertise really is. So, how do we get those numbers in the first place? Well, this brings us to the universal language of color, the system that professionals use all over the world. It's called the L star A star B star system. Honestly, the easiest way to get this is to think of lab as a GPS for color. It's that simple. Just like a GPS can give you the exact coordinates for any spot on the planet, lab gives every single color its own unique address in a three-dimensional space. No more confusion, no more guessing. So the first coordinate is L star, and the L star stands for lightness. Think of this as the altitude of your color. It's a scale from 0 to 100. 0 is pure absolute black, 100 is pure white. The higher the L star number, the lighter the color. The lower the number, the darker it is. Easy, right? Next up, we've got the A star value. If L star was up and down, think of A star as your north to south axis. If you get a positive A star value, your color is heading into red territory. If you get a negative value, it's heading over to the green side. And our final coordinate is the B star value, which is our east to west axis. A positive B star number means the color has more yellow in it. A negative number means it has more blue. And that's it. Any color you can possibly imagine is just a simple combination of these three L, A, and B coordinates. Okay, theory's cool, but let's make this real. Check out this table. We're comparing our standard or target color to the sample we produced. Look at the L star value. Our sample is 54 and the standard is 52. What does that tell us? Simple. Our sample is a little bit lighter. Now the A star, our sample is plus 4.5 while the standard is plus 6. So our sample is less red. And finally the B star, our sample is plus 15, the standard is plus 12. So our sample is more yellow. See? All of a sudden it looks a little off, becomes a precise, actionable diagnosis. Now, knowing which direction the color is off is one thing, but the next logical question is, how far off is it overall? For that, we need another tool in our belt, something called delta E. Think of delta E like this. If our two colors are two different points in that 3D color space, delta E is just the straight line distance between them. It boils down all that L, A, and B information into one single powerful number that answers the simple question, how close are we? And there are some general rules of thumb for this number. Generally, anything under 0.5 is an excellent match. Your eye probably can't even tell the difference. Up to 1.0 is usually considered acceptable. But once you start creeping over 1.0, you're in the danger zone. And anything over 2.0 is often an instant rejection. But, and this is a really big but, you have to be careful. You can't just live and die by this one number. For example, a delta E of, say, 1.5 might be totally invisible in a dull, neutral gray, but that exact same delta E of 1.5 in a bright, saturated red could look like a massive, glaring mistake. The numbers are your guide, but they're not the final judge. Which brings us right back to our main point, the reason we're all here. It's all about finding that perfect, beautiful balance between what the machine tells us and what our eyes can see. Let's think about this like a team. The machine, it's your star player for consistency and direction. It will give you the same objective data every single time. But your eye is the expert at seeing subtle undertones or noticing how the texture or gloss of a surface completely changes how a color feels. They both have unique superpowers. And this right here, this is the golden rule. If you remember one thing from this whole explainer, make it this. The machine, the spectrophotometer, tells you what is wrong. It tells you it's too light, too green, not yellow enough, but your trained eye, your eye tells you how much it's wrong, and whether or not that difference actually matters in the real world. That's the balance. Okay, so we've got the philosophy down. Now for the fun part, turning all of this knowledge into real, practical action. How do we actually fix the color? This is where it all comes together. This is your cheat sheet. The numbers tell you exactly what to do. Your machine says the shade is too dark, which means the L-star value is too low. What's the fix? You increase the white pigment or the filler. The reading says it's too green, a negative A-star value. The fix? You add a touch of red or yellow. The data isn't just data, it's a direct command for your next move. And finally, just a quick word of warning. All this amazing tech is worthless if you fall into these common traps. You have to make sure your sample is clean. You have to account for differences in gloss. Use the right background when taking a reading. And please, never ever just look at the delta E number and call it a day. You have to look at the whole picture. So there you have it. You've got the framework now. You've got the language of LAB, the metric of delta E, and most importantly, you have the golden rule for balancing the machine and the eye. So the only real question left is, are you ready to start seeing color like a true master?
On day 5 you learn lab system, delta E meaning, instrument reading, correction direction, eye plus machine balance. Tomorrow on day 6 we will do visual shade analysis without machine, 30-second eye training method, master matcher जैसे देखना. Hit the like and comment and subscribe. Thank you.